We're going to talk about solving quadratics with square roots. Solving quadratics with square roots is very similar to solving a quadratic in general. It's just this time we're going to have a square that we have to get rid of using inverse operations by taking the square root. Let's start with something basic. Here I have x squared minus 5 equals 73. What we're going to do is same process of solving a regular equation. We're going to use inverse operations to get our variable by itself. The first thing that I want to get rid of is this minus 5. To get rid of minus 5, we can add 5 to both sides of the equal sign. Now I have x squared is equal to 78. Next, to get x by itself, I need to get rid of the fact that it is being squared. Well, the inverse of squaring is to take the square root. If I take the square root of the left, I have to take the square root of the right. And now I have x is equal to the positive or the negative version of the square root of 78. And let's talk about why this is the positive or the negative version. But let's do so with a simpler problem. Let's think about the square root of 4. The square root of 4 is 2. However, 2 times 2 equals 4. Negative 2 times negative 2 is equal to 4. So actually, when I take the square root of 4, it actually has two answers, both the positive and the negative version of 2. Anytime we take the square root of a number, it technically has two answers, a positive version and a negative version. So we have the positive and the negative version of the square root of 78. If this could be simplified, we would want to simplify it. However, whenever I break down 78, I am only able to divide it by 2 by having 2 times 39. Neither of these are perfect squares, and therefore it can't actually be simplified. So my answer is simply the positive and the negative version of the square root of 78. I could write that out as x is equal to the square root of 78 and x is equal to negative square root of 78. Let's do another example. This time, I have a little bit more going on. You'll notice that our factor x minus 10 is being squared. X minus 7 is being squared, and this set is being multiplied by 10. The first thing that we want to do is we want to get rid of this times 10 out in the front. Well, the opposite or the inverse of multiplying by 10 is to divide both sides of the equal sign by 10. That leaves us with x minus 7 squared is equal to 44. Next, we need to take care of this square. The inverse of squaring is to take the square root. But if we take the square root of the left side, we have to take the square root of the right side. So now we have x minus 7 is equal to the positive and negative of the square root of 44. The square root of 44 can be simplified because 44 can be broken down into 4 times 11, and 4 is a perfect square. So if I have the square root of 4 times 11, that's the same thing as the square root of 4 times the square root of 11, and the square root of 4 is just 2. So that simplifies to 2 square root of 11. So now I have x minus 7 is equal to the positive and negative of 2 square root of 11. Next, I want to take care of this minus 7. Inverse operation says I can add 7 to both sides of the equal sign. Now I have x is equal to a positive 7 plus or minus 2 square root of 11, to which my two solutions would be x is equal to 7 plus 2 square root of 11, and x is equal to 7 minus 2 square root of 11. Let's do one more example. Here are variables on the left-hand side, but you'll notice there is numerous things happening alongside that variable. In order to isolate it, we're going to have to take several steps. Whenever we are doing inverse operations, we're doing order of operations in the opposite order. So instead of doing PEMDAS, we're going this way. We want to do the inverse in the opposite order. So the first thing we want to get rid of is anything being added or subtracted, to which I want to get rid of this plus 8. Therefore, I'm going to subtract 8 from both sides of the equal sign. That gives me 9 times the set 2m minus 3 squared is equal to 441. Next, I'm going to divide both sides of the equal sign by 9. That leaves me with 2m minus 3 squared is equal to 49. Next, I want to get rid of this exponent. You see, we've gotten rid of the addition or subtraction, we've gotten rid of multiplication or division, next is the exponent. So to get rid of an exponent of 2, we're going to take the square root. So now I have 2m minus 3 is equal to, the square root of 49 is 7, but that could be positive or negative. You'll notice that we are now kind of going back down to the bottom of this PEMDAS. We want to get rid of addition or subtraction first. So I'm going to get rid of this minus 3 by adding 3 to both sides of the equal sign. That gives me 2m is equal to 3 plus or minus 7. In other words, 2m is equal to 3 plus 7, and 2m is equal to 3 minus 7. Well, let's look at this first one. 3 plus 7 is 10, so 2m is equal to 10. My next step would be divide by 2, m is equal to 5. Let's look at our second solution. 3 minus 7 is negative 4, so 2m is equal to negative 4. Divide both sides by 2. Now I have m is equal to negative 2. So my two solutions would be positive 5 and negative 2.